So in this section, we're discussing how to simplify a square root function when we have some kind of square root in the denominator of a fraction. All right. So the same idea that we talked about back with imaginary numbers, right? Where we're rationalizing. Remember, we had some times when we didn't want imaginary numbers in our denominator. Same thing happens here. We don't want any square roots left over in our denominator when we're simplifying. With imaginary numbers, we would multiply by like top and bottom by I. The same thing is going to be used here. We're going to multiply top and bottom by whatever the square root is down in the denominator. All right. We also multiplied by the conjugate with imaginary numbers, if you remember that. Same thing is going to apply here. And we're going to talk about that later on in class. We're going to multiply top and bottom by whatever the conjugate is of that square root expression. Okay. So there's a couple of different types of problems that we'll see. We have to remember some of our basic rules of square roots, like when we're multiplying a square root by a square root, it's the same thing as multiplying those two numbers underneath one whole square root, right? So off to the side here, if you need me to show that, like the square root of 2 times the square root of 2, well, that's the same thing as the square root of 2 times 2, right? Which is the square root of 4, which is just 2. So they kind of cancel each other out, all right? Hopefully we remember that. If I'm taking a constant term like 3 and multiplying it by the square root of 3, well, those two terms can't really simplify. I'm just left with 3 root 3. I just combine them. Similar to how if you were multiplying a constant by a variable, right? You just combine those things together. Okay. Does anybody have any questions about those two quick notes here before we get going? Because we're going to see these rules apply a lot when we're rationalizing our denominators with square roots. Everybody good? Okay. So the first problem that we might see is rationalizing a denominator, and I just have a square root down there. So there's no expression. There's no constant term being multiplied by it. It's just a root by itself. All right. And very similar to what we've seen before, the first thing I'm going to do is multiply the numerator and denominator by the square root expression. All right. So I'm going to take 2 square root of 2, my original problem here. And I'm going to multiply top and bottom by the square root of 2. Okay. So I have 2 divided by the square root of 2. I'm taking the top and bottom and just multiplying it by whatever that square root term is in my denominator. Well, 2 times the square root of 2, as we see up here kind of in this quick note, those can't really combine, right? I have a constant times the square root. I'm just going to push them together. So I have 2 root 2 in my numerator. All right. I can't simplify that any further than that. But in my denominator, I have root 2 times root 2. Now there's 2 ways that we can think about this. So we can say it's root 2 times root 2. This is equal to one of 2 things. Either the square root of 2 times 2, or you can think of this as root 2 squared, right? Anything multiplied by itself is just that thing squared. Well, what's 2 times 2 going to give me? 4. And what's the square root of 4? 2. Right? What happens when I square something that's inside a square root? What would be left over? 2, right? So either way that you think about this, whether you want to think about simplifying it this way, where you're multiplying those 2 numbers inside one square root, or you're taking the square of a square root, and you know from before, like we talked about not only yesterday, but before we were doing square roots, that's going to cancel out, right? And I'm just left with whatever's inside the root, which is 2. That's pretty much what this note down here is saying, right? You have the square root of x times square root of x, or just the square root of x squared. It's going to cancel out, and you're left with everything inside that root. So what I have right now is 2 root 2 divided by 2. And that should be the case, right? Our objective is to get rid of that square root in our denominator. Well, when I multiply top and bottom by that root, these should go away pretty much every single time. So you can. We'll get to that in a second. Are there any questions about what we've done so far with our simplifying process? So Jenna brought up a pretty good point. If there is a term in my denominator there, so on the other page, I was left with 2 root 2 divided by 2. There will be times like in this example where I can actually further simplify. So I can cross these 2's out. And I'm left with just the square root of 2. Now, this would be my final answer. And it's not always going to be the case that you can simplify further. Kind of really just depends on the example, what you have left over in your numerator and your denominator, but really just depends on whatever the example is. All right. I would look to simplify as much as I can each time. Any questions about that first example? Okay. The next example, I have 25 divided by the square root of 5. Well, using the process of what we just did, how would I start this problem? What should I multiply the top and bottom by? Square root of 5. Good. Right, I'm trying to get rid of that square root in my denominator, so I'll multiply top and bottom by the square root of 5. What's going to be left over in my numerator? 25 square root of 5, right? I can't simplify that further. And what's going to happen in my denominator? So I have either, you can think of it one of two ways, excuse me. Square root of 5 squared or square root of 5 times 5. Either way that you think about this, it's the same thing. How is my denominator going to simplify when I take the square root of 5 and multiply it by the square root of 5? What's left over? 5, right? Because square root of 5 squared just gives you 5. Or if you do the square root of 5 times 5, which is the square root of 25, which is 5. So like I said, either way that you think about it, you should get the same thing. That's all right. So you have 25 root 5 divided by 5. How does this simplify? What can I cancel in the numerator and denominator? Right, the 25 and the 5. So what would my final answer be? So I have the square root of 5. But what would be left over? So if I divide each of these by 5, I have a 1 down here. What's 25 divided by 5? 5. Are there any questions about that example? Does everybody see how I got to that final answer there? Everybody good? All right. What would I do in the next example? What should I multiply the top and bottom by? Multiply top and bottom by root 2. Right, so that's another thing that you can think about doing also. So what we notice here is if I have the same thing in my numerator and denominator, I can cancel these out and I'm just left with 5, right? But if we were to go through this process, right, and I'll kind of just show this, I would have 5 square root of 2 times square root of 2. Well, what's root 2 times root 2? What's that going to give me? So I'd have 5 times 2. Root 2 times root 2 is going to give me 2. Well, if I have 10 in my numerator, 2 in my denominator, how does that simplify? To just 5, right? And that's what I get. So there will be times when you can simplify a little bit sooner than if we just go through the entire process. So make sure that you look for, like, if there's a perfect square, or look for things to cancel out in your numerator and denominator first before you move on. All right. So then 5 would be my final answer. Are there any questions about that example or anything that we've done so far? So if we see just a single root in our denominator, we multiply top and bottom by that same value, right? The next type of problem is very similar. The only difference now is if I have a denominator with maybe a constant multiplied by a square root. So I have a little bit more simplifying to take care of, all right? Our steps don't necessarily change from this though, all right? So we're going to still start by multiplying the numerator and denominator by whatever the square root term is in our denominator here, all right? So I have 3 over 5 root 5. It's my original expression, right? That's what they give me. And I'm going to start multiplying by whatever the square root function is in my denominator. Well, what should I multiply top and bottom then by? Square root of 5. Good. I'm trying to get rid of the square root in my denominator. You don't have to multiply it by the whole thing, just whatever the square root is, okay? Well, how does the numerator simplify? What's 3 times the square root of 5? Just 3 root 5, right? It can't really simplify. It's a constant times the square root function. What's that? So not, oh, yeah, sorry. So let's see how we get to that though, all right? In my denominator, I have 5 root 5 times the square root of 5, all right? This is the same thing if you visually need to see it this way. You can multiply all of these things together separately, all right? So you can think of it as 5 times the square root of 5 times the square root of 5. Well, what's going to happen when I multiply root 5 by root 5? What does that leave me with? Root 5 squared, which is just what? Which is just what? 5, right? Good. It's whatever's inside your square root. So this then becomes 5 times 5 in my denominator. And what's 5 times 5? 25. So my answer is 3 root 5 divided by 25, right? I can't simplify any further. So this is what I have here. You see that the only added layer on top of what we had done before is that now I have this extra constant term that I have to multiply through by whatever simplifies in my denominator with my square roots. All right. The biggest takeaway from today is to make sure you understand how to multiply roots and constant terms together and things like that, right? If it's a constant times a square root, you just combine them. A square root times a square root is the same thing as taking those two numbers and multiplying them under one radical. All right. So this is like the square root of 25 from the 5 times the 5, which is how I got my 5. Are there any questions about that example? Okay. Again, this note up here kind of says that. So notice that this becomes 5 times 5 in our denominator from the radicals kind of canceling out. So that's how we got our final answer. Let's do a couple more examples here. I have 5 divided by 2 root 3. Given what we just did, what should I multiply the numerator and denominator by to start simplifying? What's that? Square root of 3. Okay. Multiply top and bottom by the square root of 3. Well, what's 5 times root 3 going to give me? 5 root 3. In my denominator, what am I going to be left with? So I have 2 root 3 times root 3. Three times 2, or 2 times 3, which is just 6. So I have 5 root 3 over 6. And then this would be my final answer, right? We need to be able to see this. So 2 times root 3 times root 3. This is the same thing as 2 times root 3 squared. Whenever we square something that's under a radical, we've seen this many times now, they cancel each other out. You're left with whatever's inside your square root, which is the 2 times 3, which is how I got my 6. All right. With more practice, it should become second nature, but we need to start seeing that now. Those roots are going to cancel out, okay? And you're left with what's inside the square root every single time. Are there any any questions about that example? Okay. What should I do to start the next example? So given what we've done so far, times by the square root of 9. Well, what is the square root of 9? 3, right? So this is a little bit of a trick. See this note down here? It says notice in this last example. If you can simplify your square roots first, go ahead and do that, right? Every example that we've seen so far has been like root 2 or root 3, where I don't know what the perfect square is. If you have a perfect square, and you're going to see this tonight on your homework as well, simplify those. Let's see what happens in our numerator, right? I have 2 times the square root of 25. Well, what's the square root of 25? 5. In my denominator, I have 5 times the square root of 9. What's the square root of 9? 3. And I've gotten rid of my square roots already without having to go through that process of multiplying top and bottom by root 9, right? Don't create too much work for yourself if you can simplify to start. What's 2 times 5? What's 5 times 3? And then how do I simplify 10 over 15? What does that simplify to as a fraction? 2 over 3, or 2/3. Good. So like I said, a little bit of a trick, but also gets us to kind of remember, all right, well, how can I simplify to start? Then I'll go through my process, whether I have to multiply by that square root or not. Okay. Any questions about that example? So we've seen problems where I just have a square root underneath my denominator, and a second example when I have a constant times the square root in my denominator, right? It's pretty much the same process. Really just depends on how much you need to simplify. Are there any questions about anything we've done so far? Okay. The last problem type that we're going to see is when we're rationalizing a denominator, but we have a square root expression in our denominator. All right. And this is the example, as I was explaining earlier, that's very close to what we saw with imaginary numbers. So we were multiplying top and bottom by the conjugate, right? And if you remember the conjugate, okay, so up to the top here, we kept the terms the same in our denominator, but we changed the sign that was between them. So like if you remember, if I had like 2 over 2 plus I, what did I multiply top and bottom by to get rid of the I? You remember this? What's that? Not a negative. So there's going to be a minus sign involved, but do you remember what we multiplied top and bottom by? By 2 minus I, right? You remember this? So we kept the same thing. We just multiplied by this, we just changed the sign in between because we were trying to get rid of the imaginary numbers. Well, the same thing applies here. We're going to keep these terms the same. We're just going to change the sign that's between them in order to rationalize our denominator and get rid of the square roots. Because again, that's pretty much our objective for all of the problems that we've taken care of today. All right. Does everybody understand that idea? Are there any questions about that? Okay. So I'm going to have 2 over the square root of 5 minus 1. And if I'm multiplying by that conjugate of the square root, what should I multiply top and bottom by? So using the same idea as what I wrote here for imaginary numbers, what would be the conjugate of root 5 minus 1? Right, square root of 5 plus 1. In both my numerator and denominator. Make sure that you're doing it in both, right? And we've seen that throughout today. We're multiplying top and bottom by that value. Okay. Now, the way that we simplify that is pretty much always going to FOIL in our denominator, right? Remember the process of FOILing. Multiply the first, outer, inner, and last terms together. In my numerator, depending on what I have to start that problem, I might have to FOIL as well, or just distribute that term through, all right? So notice that I have 2 times the square root of 5 plus 1 now in my numerator. And I have the square root of 5 minus 1 times the square root of 5 plus 1 in my denominator. I would go through and rewrite it just so you're aware of what you need to do at each step along the way. In my numerator, I have that 2. It's just that singular term. So what I'm going to do is distribute that through to each term. And I would also start by just simplifying the numerator, then going through and simplifying the denominator. Don't try to do too many things at once, all right? What's 2 times the square root of 5 going to give me? Just 2 root 5, right? When it's a constant term and then a square root term, you can't combine them. Only when it's 2 square roots, then it would be like the square root of 10 or whatever. What's 2 times 1? 2. So I've taken care of simplifying my numerator. All right. Are there any questions so far? Now I have to FOIL my denominator. All right. Let's just take this step by step. Square root of 5 times the square root of 5. So I'm doing those first terms, multiplying those together. What's the square root of 5 times the square root of 5 going to give me? The square root of 25, which is just 5, right? Or you can think of it as the square root of 5 squared. They're going to cancel out. You're left with whatever's inside. So it's just 5, all right? Good. Nice. So when I do my outer terms, square root of 5 times 1. Well, anything times 1 is just itself, right? So I have plus the square root of 5. Square root of 5 times negative 1 from the inner terms is going to give me negative square root of 5. And then negative 1 times positive 1 is going to give me negative 1. Are there any questions about how I found those values in my denominator? Well, very similar to when we did this with imaginary numbers, those middle terms, notice I have a plus root 5 and a minus root 5. What's going to happen to those? They're going to cancel. Same thing happened when I was doing this with imaginary numbers. So now I have 2 root 5 plus 2 in my numerator over 5 minus 1, which is just 4 in my denominator. Right? Because I still have these like terms there, the 5 and the -1. And you can leave your answer as this. Sometimes what they will do in the book, if you ever have a homework assignment from that to kind of further simplify, they might take that 2 out of the numerator and you're left with root 5 plus 1 inside parentheses. So they take out a GCF and then they cancel these out. So you have a 2 in your denominator, a 1 in your numerator, and you have root 5 plus 1 over 2 for your final answer. You might see that. If you left your answer like this, I wouldn't take points off, right? It's all the same thing. It's just the way that they might simplify it, all right? Just as a heads up. Any questions about that example? Does anybody need more time copying this down? Okay. We're going to do one more example and then I'll explain the homework for tonight and then we will be done for today. All right. So max focus for this last one and then we'll finish up. Notice now that not only I have a square root function or excuse me, expression in my denominator, but also in my numerator. So that's going to change the way that I simplify things. All right. Whenever we see that square root expression though, I'm multiplying by the conjugate, right? It's not just a single term down there. I have multiple terms. So what would be the conjugate of this square root here? Very similar to what I did in the last example.
6 minus 4.
Good. So multiplying top and bottom by 6 minus the square root of 3. Good. So then in my numerator, I have 9 minus the square root of 3 times 6 minus the square root of 3 divided by 6 plus the square root of 3 times 6 minus the square root of 3. And what do I have to do in my numerator and denominator now? What's that process? So distributing or FOILing, right? Distributing usually is just when it's one term, but notice that I have 2 terms in both of my expressions here. So I'll start by FOILing in my numerator, all right? When I multiply the first terms, I have 9 times 6. What's 9 times 6 give me? 54. I have 9 times negative root 3. What does that give me when I do 9 times negative square root of 3? Right, just negative 9 square root of 3. Just be careful about your sign changes, that's all. What about 6 times negative square root of 3? Ultimately the same thing, right? So what would it be? Negative 6 square root of 3. And then negative root 3 times negative root 3. Well, what's a negative times a negative give me? A positive. And what's the square root of 3 times the square root of 3 going to give me? Just positive 3, right? Because technically that's square root of 9, and square root of 9 is 3. Are there any questions about how I got those values in my numerator? So how I simplified that so far by foiling? Everybody good? In my denominator, I have to FOIL as well. What's 6 times 6 give me? 36. 6 times negative square root of 3. What's that give me? Negative 6 root 3. 6 times positive root 3. Just a positive 6 root 3. And then what's positive root 3 times negative root 3? Positive or negative? Negative, right? Because I have a positive times a negative, so I have a negative. But then you're right, that's still root 3 times root 3, or root 9, and the square root of 9 is positive, or is 3, right? Are there any questions about how I found those values in my denominator? Really take your time with the foiling process. Do exactly what I just did, right? Take the first terms, outer terms, inner, last. Be careful about sign changes, right? Be careful about how square roots simplify and cancel out, or just stay the same and kind of just tag along. Everybody good so far? From here, I got to combine like terms, all right? So I had the 54 and the 3. That'll give me 57. Negative 9 root 3 minus 6 root 3. What does that give me? If I do negative 9 root 3 minus 6 root 3. So one thing that hopefully we understand is when we're adding or subtracting these square root terms together, the square root just tags along, right? Think of that almost as like a variable, right? So think of this as like negative 9x minus 6x. What would that give you? It's negative 9x minus 6x. Or what's negative 9 minus 6? Negative 15, right? So it's negative 15, that root 3 just tags along. All right, it's literally just combining like terms. In my denominator, the 36 minus the 3 will give me 33. What happens to the negative 6 root 3 and the positive 6 root 3? Cancel out. And that should always be the case. Those middle terms should cancel and you're not left with any square roots in your denominator. So my final answer is 57 minus 15 root 3 over 33. Okay. Any questions about that last example or anything that we covered today in class? Any questions at all? Okay. Your homework for tonight, you see here, it starts on the bottom of this page. It's in the packet. So like I said, for those of you that are at home, make sure that you access that. Showed you where it is in the folder for today. You're going through a list of problem types, very similar to what we saw today. Make sure that if you can simplify first, you go ahead and do that and then work through your process. There's a square root alone, multiply top and bottom by that root. Even if there's a constant times the square root, you're doing the same process. You see in 5 and 6, you have some problems with multiplying by that conjugate, just going through and simplifying, right? One where you might have to distribute, one where you have to FOIL in your numerator and denominator. All right. When we come in tomorrow, so you see here in the folder for today, the assignment is in the note packet, so access that and then submit it there. When you come in tomorrow in the class, we are going to review the homework from today, and then we are going to continue just practicing section 6.5. So going through pretty much each problem type and solidifying that point for us. And then we'll move on from there. Okay. Any questions about anything that we covered today or about the homework assignment or our plan for tomorrow? Okay. With that being said, then you can go ahead and sign off. Those of you that are at home, you got a couple minutes here. Those of you that are in here, just wait for the bell to ring. I'll see you all tomorrow. Make sure you get your homework assignment done and enjoy the rest of your day.
Have a good one.
You too. Take care.